Ground telescopes have always been human civilization's first big window onto the universe. By collecting many more photons of light than the human eye could possibly detect, they allowed us to map the constellations, follow the motion of planets, and even find entire galaxies far beyond our own. For centuries, astronomers have worked to polish and remake these instruments, each generation creating something just a little bit better, just a little bit more powerful than the one before. And yet, no telescope in the world has ever come close to the groundbreaking leap that human civilization took with the James Webb Space Telescope, more commonly referred to as JWST. This telescope was designed for one ambitious reason: to gaze farther into the universe than has ever been possible before, to unveil the birth of stars, galaxies, and even potentially life. It was constructed not just to examine what we have today, but to look back billions of years and see a universe in its infancy. Since its launch, JWST has exceeded expectations far beyond its mission. It has completely changed how we view the universe and made fundamental questions regarding our place in it. Perhaps the most remarkable milestone came early on, when scientists announced pictures that might be read as the city lights of Proxima b, a rocky exoplanet that circles the star Proxima Centauri slightly more than 4 light-years from Earth. Whether or not this actually constitutes evidence of civilization is still up for debate, but the photograph itself was something unlike human experience. To build it, Webb's 18 mirror segments each took individual bites of light, then assembled them with breathtaking accuracy. The result was one sharp image, a testament to the strength of engineering and scientific vision combined. It was just the start, a first look at what the telescope was capable of. Shortly thereafter, Webb took the best photos ever of another far-off exoplanet, solidifying its status as the most powerful human eye ever placed upon the stars. How exceptional is JWST, beyond the loveliness of its photographs, is that it lets us glimpse history. Through its instruments, scientists are able to go back in time to when the universe was just 200 million years old, a small percentage of how old it is now. Each photon it collects has a story from the past, coming after traversing billions of light-years. Through this way, Webb is not just a telescope, it's a time machine. We can observe the very first galaxies form, see the first stars light up in the dark of the universe, and behold the creation itself come to life through its lens. Peering so far is made possible by its enormous golden mirror, 21 feet in diameter, shining and unearthly. The mirror collects the feeble light of distant stars and sends it back onto 4 highly specialized instruments, each tailored to a specific task of deciphering the universe. The near-infrared camera takes clear, stunning photos of nebulae and galaxies. The near-infrared spectrograph breaks up starlight into its components, uncovering secrets about atmospheres, chemical compositions, and planetary systems. The mid-infrared instrument is designed to detect heat and is ideal for examining cooler exoplanets, distant galaxies, or icy bodies in our solar system. And keeping it all on course is the fine guidance sensor, stabilizing Webb's target and keeping it razor-sharp, allowing measurements with a precision no telescope has ever attained before. You would wonder, why infrared light? Why not visible light? The reason is in the very nature of the universe. Visible light is too readily stopped by clouds of dust and gas, the raw materials out of which stars and planets are born. Infrared, though, gets through these veils and lets us glimpse into the secret nurseries of creation. Infrared finds cooler, dimmer objects as well, newly formed stars, rogue exoplanets, and distant galaxies pulled in by the universe's expansion. By using infrared, Webb observes what no other telescope would be able to uncover. One of its accomplishments that caught the imagination of the world was the first ever direct image of an exoplanet named KIP 65426b. This behemoth planet, which was found in 2017, is a monster, 12 times Jupiter in size, and it revolves around its star at a huge distance, over 100 times greater than the distance Earth orbits around the Sun. Getting its picture was an engineering feat. Webb took several images using different filters to pick up different wavelengths and merged them into one image that showed the planet's light with amazing detail. Astronomer Sasha Hinckley of the University of Exeter described the moment as a paradigm shift, not just for Webb, but for astronomy as a whole. While HIP 65426b is too large and unfriendly to support life, understanding it is important. By observing directly, scientists are able to study atmospheres, makeups, and the constituents of entire worlds. These methods open the door to looking at smaller, Earth-like worlds in the future, worlds with oceans, continents, and even maybe civilizations. Direct imaging is the beginning of answering one of humanity's oldest questions: are we really alone in the universe? Webb has not just imaged planets, but gazed into the farthest depths of space, uncovering galaxies that existed when the universe was only 2% of its current age. The light coming from these galaxies took 13.4 billion years to arrive, so Webb is seeing them as they were just a short time after the Big Bang. To find them, astronomers employed sophisticated methods of separating these distant smudges from the light of younger stars and galaxies. Once found, Webb's spectrograph measured their redshift, indicating how stretched the light had become as space itself expanded. Some galaxies had a redshift of 13.2, record breakers, placing them in front of humanity's oldest cosmic structures ever observed. Such finds redefine our knowledge of the early history of the universe. Galaxies, astronomers long assumed, were built up slowly over time. But Webb has revealed that huge galaxies existed long before they should have, teeming with stars ablaze in the primitive universe. It compels scientists to rewrite their theories of galaxy creation and rethink even the timeline of cosmic evolution. Perhaps, though, the most disturbing possibility does not reside in galaxies but in civilizations. Webb's sensitivity raises the question: would it be able to detect alien worlds' artificial light? One favorite candidate mentioned is Proxima b, orbiting its red dwarf star only 4.25 light-years away. It lies within the habitable zone where liquid water might persist. If tidally locked, one side is scorching in perpetual sunlight and the other in perpetual darkness. A civilization that could harvest solar energy on the sunny side and light up the dark side with enormous webs of artificial light. Astoundingly, studies indicate Webb might theoretically find such light if it radiated within certain wavelengths. Ponder aiming the telescope at that planet and seeing a glow not of starlight, but of technology. Such a find would not only indicate we are not alone, it would indicate that intelligence, similar to our own, has evolved elsewhere in the universe. Future telescopes, even more sensitive than Webb, may one day find these weak glows of extraterrestrial cities. The implications are astronomical. For centuries, mankind gazed up at the stars in awe, creating myths and legend about what they saw beyond. Now, through Webb, we have a machine that can seek out answers, not only to scientific questions but to questions of existence itself. With each new photo it brings back, whether of a roiling nebula, a distant planet, or a group of ancient galaxies, it serves as a reminder that we are part of something infinitely greater than ourselves. Each discovery opens the door to new questions. What ignited the earliest stars to shine? How did galaxies coalesce in such haste? Might life be blooming beneath other suns? Webb doesn't just deliver data, it encourages humankind to dream, to stretch, and to find meaning in the expanse of space. Its purpose is not just scientific, but profoundly human, as it reminds us that curiosity is as much a part of our survival as breath itself. And so our adventure with the James Webb Space Telescope goes on. It is not the last word in astronomy. Other telescopes will come, even more powerful, but it is the biggest leap human beings have ever made out into the unknown. It has opened up the sky as a huge archive, a history of time and of creation, and invited us to read it. The universe is immense beyond comprehension, and yet here we are, a tiny species on a pale blue dot, with the temerity to look out and ask questions. With Webb, we are no longer in the dark about the earliest pages of the universe. We can observe the light of the first stars, the formation of galaxies, the glint of distant planets, and even perhaps the remains of civilizations older or smarter than our own. That's our journey for today. What do you guys think? Is the James Webb Space Telescope the ultimate weapon to unlock the secrets of the universe, or is it just the precursor to even more amazing discoveries to be made? If you liked this trip to space, be sure to like this video, subscribe to our channel, and enable notifications so you don't miss an update. The universe is only starting to show us its secrets, and we together will be present to see them.